All right, guys. So yesterday, this is where we stopped at, making sure we had a good understanding of where our inverse functions could happen at. What are their domains? What are their intervals for their range? And basically, what quadrants are we looking at on our unit circle? Okay. So as you can see here, there are a couple similarities. So for sine, tangent, and cosecant, we're in quadrants 1 and 4. For cosine, cotangent, and secant, we're in quadrants 1 and 2. Okay. How I remember that is that it's when sine is dominant. Okay. So when sine is dominant is 1 and 4, meaning that obviously sine inverse, cosecant inverse, and with tangent, sine is your numerator, right? And then for the other quadrant, cosine is dominant. Cosine, it's inverse, secant, and then is reciprocal, secant, and this time cotangent, cosine's in the numerator. So those three are going to share. Okay. Any questions on that so far? All right. So what does it mean to find the degree measure of theta? It literally just means to give me the degree measure, right? There's nothing more, nothing else to that. So if I ask for arctan of 1, remember arctan is the same thing as saying tan inverse. So if I'm looking for theta equals tan inverse of 1, it's the same thing as saying arctan of 1. So we're asking ourselves, at what point do I have y divided by x equal to 1? Does that make sense? That's what you're asking yourself. So at what point? And tangent is what, 2 quadrants? 1 and 4. So quadrant. So when do I have y divided by x equal 1 in quadrants 1 or in quadrant 4? In order for something to be equal to 1, what does that mean they have to be? The numerator and denominator have to be the 45, because that's the only way that they are the same. Okay. So first off, we know that it's in quadrant 1 because it has to be positive. And second, it would be 45 because that's where your x and y are the same. Okay. On this one, it's saying theta equals secant inverse of 2. So secant is the reciprocal of who? Cosine, right? So if your secant theta equals 2, that means your cosine theta equals what? 1/2. So you're asking yourself, when do I get 1/2? Well, what quadrants am I going to look for a cosine? Cosine is what quadrants? First and second. So quadrant 1 and quadrant 2. And it needs to be positive. So which quadrant does it fall in? The first one. So in quadrant 1, when does cosine theta equals 1/2? And in terms of coordinate points, cosine is my what? Your x. So I'm asking myself, in quadrant 1, when is x 1/2? 60 degrees. Okay, so you establish that it has to be in quadrant 1 or 2. And it has to be in quadrant 1 because it's positive. And when you look in quadrant 1, that takes you to 60. Huh? Oh, you're fine. How do we feel? So the hope was the bell ringer would make it, get you warmed up, like, okay. And then now we're doing examples similar to the bell ringer. Does it solidify what we're doing? Yes. What are your questions for me? None right now? Yes. Are we good? Okay. All right. Now, does it make a difference when I ask you for the radians? No, it does not. So, -3. So when I think about -3, is there any way that cosine will equal -3? No. Okay, there isn't, right? For my table, cosecant. On my unit circle, I can't get -3. So that tells me that this has to be done in the calculator, right? If it's not a value that I can come from my unit circle, that automatically tells me that I have to use the calculator, okay? In the calculator, to put in the inverse, the reciprocal inverse, you have to convert it into its reciprocal value, okay? So if the cosecant is -3, then therefore the sine inverse has to be -1/3 because they are reciprocals of each other, correct? So in the calculus, and you have to do that with all the reciprocals. Mhm. Same thing. You just have to think about it. So it's 1 over that decimal, right? Okay. So this is what we're inputting in the calculator. So we then would put in sine inverse -1/3. And that's going to equal our cosecant. Okay. So we go to the calculator and we type it in. And we get our value. If you did not get that value, make sure that you're in radian and not in degree mode. Are we comfortable going from in between the reciprocals? Yes, doable? Perfect. No, you could. All right. So now someone asks, what happens if it's a decimal? Okay, when there's a decimal, that means that you're putting it under 1. Okay, so cotangent is a reciprocal of tangent. So when I put it in the calculator, I need to make sure that it's in degree mode first because it's asking for the degree. Okay, and cotangent, it's normally quadrants 1 and 2, right? But because I have to convert it to tangent, that means I can be in 1 and 4, correct? I'm going to fall in 1 and 4 is the value it's going to give me. Does that make sense? All right. Negative cotangent means that, and a negative tangent means that I'm going to be in the, so to counteract that, we have to add 180. This is the angle on the other side. Anytime we're not in a quadrant we're allowed to be in, we have to counteract that. We add the 180. So for example, we know that cotangent is in quadrants 1 and cotangent's in 1 and 2. But I have to use tangent in the calculator to calculate that. Does that make sense? And tangent's going to be in 1 or 4. Exactly, because we have to use reciprocal.
And you can go to 1.
I can't go into there. So in order to get that, I'm gonna have to add the 180. I have to counteract it. Okay, because that's the only way. So when I type it in the calculator, I'm typing in 10 inverse of 1 over -0.3541. But I'm going to add the 180 to ensure that I am going that extra 180 to quadrant 2. Does that make sense? Because it could be in quadrant 1. They would share quadrant 1, right? But because of that negative, we don't share quadrant 1. It has to be in quadrant 2. So put it in the calculator, and you should have gotten 109.499 degrees. Okay, so like America said, if it had been positive, would I have had to worry about it? We would have been where we could be. We would have been in quadrant 1, and everyone shares quadrant 1, right? But because it couldn't be in quadrant 1 because it's a negative, that's why we had to add the 180. Okay. How do we feel so far about calculator? Good. Okay. So be careful when using the calculator to evaluate the inverse cotangent. Okay. of a negative quantity. So be very careful when you're doing the negative quantity for cotangent. Yes. Okay. Okay. You're going to enter the inverse tangent of the reciprocal. Okay, which is what we did, right? So just be careful and be mindful when you're dealing with that. Got it?
So that 180, right?
That 180.
If you said if it was negative, if it was positive, we would add the 180.
Yeah, if it was positive, we would have fine. It's the negative that's our problem. So be careful when you're dealing with the negative.
Oh, I didn't. Yeah, it's because I. Okay.
Yeah, and if it's in radians, instead of adding 180, you could be adding pi. Because 180 equals.
Wait, why
pi.
are we adding pi?
180 equals pi. So if it wanted a radian value, we would have to add pi instead of 180.
If it was negative, right? Okay.
If it was negative. This only applies when you are dealing with the negative quantity. Okay? And if it's multiple choice, more than likely they're going to have your first answer and the answer without adding the pi, right? The question is, are you going to get tricked? No, you won't. That's why we're saying caution, red flag, stop. All right. Okay, now multiple expressions in the calculator. So you can combine multiple trig functions and expressions together. So notice here this is saying tan inverse of 3/2. The reason why this is okay is because tan inverse is going to give you a theta value. Does that make sense? It's telling you the angle. So now you're going to find the sine of that angle. Okay, so you can think about it as in parts, or you can just type it all in the calculator at once. Okay. If you think about it in parts, you're finding what angle makes this true first. And then once you have that angle, you're then going to find the sine of that angle. Okay. So again, in parts, we would do tan inverse of 3/2. So we're asking tan theta equals 3/2, right? So tan theta equals 3/2. That's going to tell us our restrictions on where it can lie. So tan only is in quadrants 1 and in quadrant 4. Agree? Okay. And it's positive, so it has to be in quadrant 1. So the angle we're using is in quadrant 1, which is cool because everything is what in quadrant 1? Positive. So our sign is going to be positive. Yes. All right. So we would draw it out. So here's my triangle if you're doing the exact. So notice that have not picked up a calculator yet. Do y'all remember this from unit 4, chapter 4? Creating the triangle. To find the radius, x squared plus y squared equals r squared. Yes. Pythagorean theorem. Okay, so I have my triangle drawn out. And this is doing it completely and utterly by hand. Okay. So it's asking for what angle makes 3/2. And I'm looking for the sine of that. So when we do the math, we're asking for tangent is what? It's 3/2. Why are we doing this completely by hand? So now if I need to know the sine of that angle, how do I find the sine of this angle? Well, it's already drawn out. So I have the angle. So sine is what over what? Opposite over hypotenuse. What's my opposite value? What's my hypotenuse? Square root of 13. So 3 over the square root of 13 equals 3 times square root of 13 over 13. That's my exact value. Okay. You can check yourself if you're like doing it as homework by inputting all of that into the calculator. So I'm going to go to my handy dandy. Sylvie went crazy yesterday. Oh my gosh. She's still going crazy. She's still weird. Oh, she has to be reset. She was tripping. She was still trying to follow that trig function. She made me mad. Hey girl, welcome back. All right. So if I'm doing this by hand, right? By calculator, it'd be sine, second, tangent, 3 divided by 2. 3 divided by 2, close parentheses, press enter. That's the value, right? Using the calculator. If it asks for an exact value, an approximate value, cool. But if you're looking for the exact value, you're going to have to create your triangle and find it, okay? So I can check myself. This is what I got for my exact value, 3. So I'm going to do 3 square root of 13 divided by 13. If I'm right, then these two answers should be the same. Are those two answers the same? Yes. Okay, so it's a way while you're doing your homework to check yourself. If they're asking you for the exact, then draw your triangle in the right quadrant. Fine. Going back to Sakatoa, right? So use Sakatoa, find the value that it's asking you for. But if you're not confident in your exact answer, you can type in the original in the calculator and see if you're getting the exact same decimal. Okay. And are we geniuses? Today we are. We'll take it. So let's try this one. So this one, it says cosine inverse of -5 over 13. So for cosine inverse, what quadrants are we in? 1 and 2. And since it's negative, we're going to be in what? 2. Remember, your cosine is your x over your r. Your x over your r. So we know that this is -5 and that this is 13, right? What is our y? Do y'all remember? It's 12. Our y is 12. So it's saying of the angle that makes this triangle, it wants you to find the tangent, right? And tangent equals what? X, y over x. So our tangent equals what? What's our y? Opposite over hypotenuse. So 12 over y. So -12/5 is the tangent. Does that make sense?
That's the approximate.
So your tan theta, for this is the exact actually, because -12/5. That's your exact. You're gonna put in the calculator and check yourself? I'm not mad at you. Uh-huh. Okay. So we did our cosine. We knew what quadrant we lied in. We are in quadrant 2. We drew our triangle. We found our missing y value. And then we found our tangent, which is -12 over 5. You could, yeah. So we got it. We feel good about finding exact. Yeah. All right.
Oh.
Without a calculator. Okay. So we're looking for, we have arctan, which just means inverse tan. So we need to know, when does tangent equal square root of 3? And when does sine equal 1/3? We can do the tangent one with our unit circle, but can we do the 1/3 with our unit circle? Can't. We cannot. Okay. What are the two quadrants we're working with here for tan and sine?
1 and 4.
1 and 4. So they're positive, so we're in quadrant 1. So we know that we have to be in quadrant 1. Okay. So we know that the tan of angle A equals the square root of 3. And the sine of angle B equals 1/3. So we're working with two different angles here. One who has a tangent of square root of 3. A is easy. What is A? A is pi over 6, right? We agree with A being easy because we can use our handy dandy unit circle and our big brains to do y divided by x. Yeah, okay. So A is our easy guy. Wait, no, that's cotangent, 60. Yeah, it's 60.
Wait, tangent 60?
Yeah, A has to be 60 here. So A is 60 degrees. It rains. It smells in my room? In the hall? Oh, is there a gas leak? Or something? Oh. Oh, that it's a different. Oh, I got you. I got you. I'm there. It's a different gas.
Currently burning in the building. I don't know, and they're not wasting. Y'all, I mean, I'm not the only one.
Because of this lovely glass wall, this glass wall cuts off things for me now. So I don't know what happens. All right. So you're fine. So we know that A is 60, right? Agreed? All right. What is our B? B we asked for 1/3. So we have 1/3. So what did we need? Forgot that quick. Sine. So what is the sine of B? So sine of B is, what angle makes that? Yeah, it's just, we're gonna have the angle. So we now are doing our cosine. So we do A plus B. We gotta find our cosine. Back to chapter 5. Back to chapter 5 we go. No, it's not. You have your sine and cosine. Do we have all sine, cosine? What is our sine of A? Square root of 3/2. What's our cosine of A? 1/2. Yes. What is our sine of B? 1/3. What is our cosine for B? 2 square root of 2/3. So we have all of our values in order to find the sum.
See, I got lost
We're
here.
gonna have that
No?
on the test.
What, your angles?
Like, we're gonna have to find sine and cosine of one thing, and then apply together and.
Possibly, yeah. I'll be nice if it does, and I'll give you the big babies. All right, cosine. So the sum of two angles for cosine, it says it's our cosine A times our cosine B minus our sine A times our sine B. Remember that? Okay, do we know the values of A, B? So we're just now plugging in. Does that make sense? We're only gonna plug in. So cosine of A, cosine of B, sine of A, sine of B. Yeah. Yeah. So we drew our two triangles.
They want this in degrees?
I don't think it was. Was it degrees? No, I was just telling you it was at 60 degrees. It's gonna just give you that fraction, the exact answer. So we plug everything in. 1 times 2 square root of 2 minus square root of 3 all over what? 6. That's it. That's your answer. Can't go no further. That is your exact answer. If you didn't believe your exact answer, what would you do? Use the calculator to check. So you would plug all of this in for the original, get a decimal value, plug that in, get a decimal value.
So wait, you said we couldn't find sign because it was hard or something. I messed up on
We
that.
couldn't find sine using the unit circle.
Okay, so then what did we do?
So we drew out our triangle.
Why don't we- the values go on the triangle?
Remember our rules, y over r, x over r.
So it's all like the same.
Yep. Oh, that's why that's the hardened bread. That's why we learned that first.
Arctan still just means the inverse, right?
Arctan means the inverse. You don't know your theta. Yeah. Okay. All right. You want to try it again? Oh, well. This was not bad. This was not bad. It's a double angle. But what is a double angle rule for tangent? If you have your identity sheet that you made for your test or something, what is the double angle rule for tangent? What do we need?
The two tan A, 1 minus tan 2 A.
Exactly. So we're going to need to find the tangent of this sine, right? So sine is positive. So that means it's in quadrant what? 1. So we're going to draw our triangle in quadrant 1. Okay. And tangent sine is your opposite over your hypotenuse. So we know that our opposite is 2 and our hypotenuse is 5. And we need to find our x. So that's going to be 5 squared minus 2 squared. It's going to give us our x. What is 25 minus 4? 21. So x is the square root of 21. Okay. Can I now establish what tan theta is for this angle? So tan theta equals your opposite over your hypotenuse. I mean, your opposite over your adjacent. So we have 2 over the square root of 21, which is 2 square root of 21 over 21. And then what did you say the double angle rule for tangent is? So tan 2a equals what? What did you say, Lipe?
A, and then 1 minus
Tan what?
A,
Tan A,
1 minus tan.
1 minus A. So you have your tan of your theta, and you're plugging it in and cleaning it up. So tan A is 2 square root of 21 over 21 divided by 1 minus 2 square root of 21 over 21 squared. And you would clean up, keep, change, flip, and that would be your answer. Remember, trig is a build of each other. So like, you're going to pull a little bit from each chapter to the end.
Supposed to be taking the first for
It's going to be, well, we won't be here on Thursday, so I'll just put it on your math lab.
so it's gonna be all
It'll be on. I mean, oh, it'll be on your bright space.
Or -2?
And there you go. Okay. I'm gonna erase my ink so you can see it pretty. So we're gonna use a double angle. Oh, I forgot my tan in the top. Plug everything in. So you use Pythagorean. Did we get that? Did we get 2 square root of 21 over 21? Yes. And then we plug it all in. So now we're plugging everything in. We forgot the 2 in the numerator. Station.
No, I didn't. I put it on my own.
Mhm. And then you do the math. So you get 4 square root of 21 over 21. In the denominator, you have 1 minus 4 times 21 over 21 squared. You're going to combine. Once you combine, you're going to keep, change, flippity flip. Once you flip, your 21s are going to cancel out, and you're going to be left with 4 square root of 21 over 17 is your exact value. Okay, when our fractions start becoming double deckers, that's where it starts getting a little funky. Talk to me on that math. That's it, by the way. You're good, America.
But he didn't.
America's I'm out of here. Which part?
Okay, I got the.